For example, we talk about circles, and circle is just there are just two parameters that will define a circle. Its center, right, and its radius. If you're only given the radius, then there could be infinitely many circles with that radius, because we don't know the center. Where do we start? If you have a drawing compass, then where do we start pointing the needle of the compass? And if only have the center, then it could also have create as many circles depending on what the radius is. So if you're given the center and the radius, then there's only one unique circle that satisfies that. And then after that, you divide a circle in half, right? And then that's what we call a semicircle. Have the circle divided into half, semicircle divided further into whatever you know parts. So basically an arc is just a subset of a circle, right? And that's it. And now you have the circle, which is that you have the center. The center is not part of the circle, right? It's not. And we have the interior of the circle, the area in the interior. The interior is the area inside it, and then you have the exterior, the area outside of it. So you have a circle which is defined by a center and a radius. And if you connect 2 points that are 2 points, any 2 points of a circle, right? Any two. So you select two and then you connect them. That's a chord. If you connect 2 points on a circle, which happens to also pass through the center, then that's the diameter. The diameter actually consists of two radii. Radii? Two radius. Radii. I'll say two radius because I can't for the life of me pronounce radii or radii. Anyway. So diameter, this is diameter is formed when you connect 2 points on a circle, which happens to also pass through the center, right? So basically, parang, yeah, it has to pass through the center. So that's the diameter. Basic, right? We all know that since kindergarten, maybe since grade school. Now, so those are chords. You have now chords diameter. Now let's connect. Let's connect, or rather form angles. Basically an angle consisting of two chords and a vertex, which is a point on the circle. So it's actually just two chords with the same common endpoint, right? Like that, something like that. So the vertex of the angle is on the circle. The vertex of the angle is a point on the circle, and its sides are chords of the circle. Technically, an angle is a ray that consists of two rays. So basically, it's the same angle. If you extend these chords in all directions, it would still be the same ray. It's same angle, right? So that's an inscribed angle, right? So this is an angle whose vertex is a point on the circle, and whose sides are chords of the circle. Okay, so the thing about it, inscribed angle, since I started here, is that the measure of the inscribed angle is one half the measure of its intercepted arc. What is it, intercepted arc? Um, so it is a arc whose endpoints, or basta intercepted arc. I'll just show it. Hirap explain. Meron siyang definition. I'll just show it, but I, I can picture it out, but I can't, actually spit out. I can't say the definition, but I know exactly what it looks like. So basically, So the area of the area, the measure of the inscribed angle is one half the measure of its intercepted arc. So that's the thing about inscribed angles. What is the measure of the inscribed angle whose intercepted arc is a semicircle? What is the measure of the inscribed angle of an inscribed angle whose intercepted arc is a semicircle? And of course, since then its measure has to be one half of 180. Diba? Semicircles half a circle, so 180, and therefore the degree measure of an inscribed angle whose intercepted arc is a semicircle is half 180, which is 90 degrees, which is a right angle. So that's one of the results about inscribed angle. Central angle is an angle whose vertex is the center of the circle, hence central, and the sides are radius, two radius of a circle, right? So central angle. What can we say about the central angle? Central angle, it's actually quite easy because the measure of the central angle is this. The measure of the central angle is this. The measure of a central angle is equal to the measure of its intercepted arc. So now we go to tangents and secants. A tangent, basically a tangent, start with a tangent line. Tangent line is a line, obviously, which intersects the circle at only one point. Thing about tangent line is when you, well, it intersects at a point, at only one point. And of course, if you draw a radius from that point to the center of the circle, you have a radius, obviously. If you draw, if you connect that point of intersection, which is called a point of tangency. Now, the angle formed by the tangent line and the radius is actually a right angle, perpendicular. In other words, they are perpendicular. And that's the property of a tangent line. Now we go to secant line. Now we go to secant line. Secant is rhyme, sort of sounds like second. And when you second, that's number two, right? It's number two. Meaning, a second line, uh, a second line intersects a circle in 2 points. So that's the second line. And I think that's really what we are going to study in the rest of the time, third quarter.